Hello and welcome. Can you guys see my screen sharing?
Yes,
Yeah.
ma'am.
All right, great. Okay, then we will go ahead and get started. It's 4 o'clock. Remember, as usual, before or after, whenever you ask your questions, you can go ahead and make a note of those in the chat so we'll have a record. And really, at this point, anybody can get started.
This is Maria. I'm gonna ask a question in regard when I first started doing this last night. I was actually the other night. I was having trouble with the procedure.
Uh-huh.
We're supposed to close out this, complete the circle. I mean the circuit to
Uh-huh.
connect the resistor, right?
Yeah.
Because when I first started doing it a couple of times, I was just making like a straight line and nothing was going on. But
Uh-huh.
after I connected all of the wirings together and I started getting, I guess, the proper circuit, is that what it's supposed? Mine looked like a square. When
Yes.
okay,
Yes. So and no. Okay. There. So are you guys working from a schematic or you're supposed to make it or, yeah.
well, in the lab, it says, like in that link, you're supposed to
Mm-hmm.
draw, the resistor. Then you're supposed
Mm-hmm.
to go in and draw the source, the two circuit, yeah, like that. But I guess through the instruction, I felt a little, but
Yeah.
after I did that, after it looked like that, like what you're drawing,
Mm-hmm.
it basically worked. Because I wasn't getting any, you know, I
Current
wasn't getting
flowing is
any,
what they call
yeah,
it.
yeah.
Yeah. And they call these circuits a closed loop is the term that you often hear. So yes, when you have a source, so this is your battery over here, the plus is the long side and the minus is the short side, which corresponds with like an actual physical battery that you might see in real life. There's always a positive and a negative terminal.
Okay.
And there has to be a path. You can imagine electrons flowing out of here. And there has to be a path for them to go around your circuit and come back to the negative terminal.
Okay.
So if there's not a place for them to go, then they don't flow. And that's called an open circuit.
Okay.
Usually when we hear just kind of the colloquial term for an error in electronics is a short. And that would be if there's a direct path between the plus and the minus and there's no resistance. That would mean that your electricity flows unimpeded and basically it fries the battery real quick.
Okay. All right.
So basically you have to have some connection between the positive side of your battery and if there's one circuit component, which is what you call a resistor or anything else you might put in a circuit. So you have to have something connecting here. And then you have to have, there's always two terminals in your circuit component. You have to have something connecting from the other terminal to the other side.
Okay.
So in real life, a resistor is a little thing that looks kind of like a grain of rice. It looks like this. And usually it has stripes on it to tell you what it looks like. And so you have to stick a wire, and oftentimes there's some kind of board, clip, something that holds them. So you have to stick a wire from here to your battery, like a little whatever kind of cell you have, or a power supply if that's what they've got in the lab.
Okay.
Like, and you literally have to have, and you guys are used to seeing the little batteries that kind of have a little button on one end and have a little smooth thing on the other end,
Mm-hmm.
right? And oftentimes this will be in a case of some sort. So you just have to, but you literally like, this is a wire and this is a wire.
Okay. Gotcha.
Okay. So that was just kind of some extra background trying to like help you guys connect like real life with simulation and all of that. But hopefully that answers, I'm sure you're not the only person with that question.
Yeah, it really stumped me at first because I was like, okay, am I doing this right? But after I connected all of the wiring, including the resistors, it helped. It made sense.
Okay, good stuff. All right, anyone else? People with questions? I will look at the forum. I think you guys have been doing really great in the forum lately about having a conversation and answering each other's questions. But I will just look at what's going on in there and see if there's anything outstanding that we should talk about.
I have a quick question just to make sure I'm reading it correctly on number 4.
Yeah.
When it talks about how it's set to default, but you have to multiply that times 1,000 to convert to ohms. So then the 40 times 1,000. So I'm going to be typing in 40,000 in that box, correct?
I am not looking directly at the labs. I'm not quite sure what you're referring to. Can you read the whole line, what it says?
Yes. Okay. So number 4 is right click on the resistor and choose edit. This will allow you to set the resistance. Set the resistance to 40 ohms and record this value in table 1. And then it says, note the resistor's default value of 1 kilometer is not, or 1K, is not 1 ohm. Remember, K is kilo, so 1K is 1,000 ohms.
Okay, yeah, so when you're handling that, so ohms, resistors are almost always, like a resistor ohm value in the single digits is actually really, really low. So normally you will see, let's go ahead and just use the example 1 kilo ohm. This is a Greek omega. That's the abbreviation for ohms. So basically this right here just means times 1,000. So anytime it says kiloohms or whatever, just make sure that you know that the K itself represents a number. So you multiply it 1 times 1,000 ohms. And then if it was 2 or 5 or 10 or whatever, and you will have like, when you're talking about ohms, the kilo ohms and things, you might have double digits or even like hundreds of kilo ohms or whatever. So this is actually 1,000 ohms. Likewise, when you see, and people make this mistake quite frequently with your amps, 1 amp is actually quite a lot of current. So if you have electronics, you usually have milliamps, which is a little m, capital A, and that's divided by 1,000.
So when the this is Maria again. Is so when we have to convert that milliamp to amp, right?
Yeah, so your tables should all have headings, what the unit should be. Okay. So if your lab is displaying something and it says milliamps or kilo ohms, and then your table is asking for amps and ohms, then yeah, you need to do the math and make sure that it's going into your table in the unit you're asked for. Okay. And you know to go ahead.
No, I was just saying thank you for clarifying.
So this is Ohm's law, how it's usually written, V equals IR. So your voltage, which is what's your battery value, is your current times your resistance. You notice right here, if you have your current, which is usually in milliamps, and if your resistance is in kilo ohms, then that actually multiplies out to be the same, because milliamp is divided by 1,000 and kilo ohm is times 1,000. So those units, this is usually how they write units, the units of that actually turns out the same as amps times ohms, or actually the whole number, because one is multiplied by 1,000 and the other one's divided by 1,000. So if you just multiply it together, you get amps times ohms, which is volts. So yeah, you can still come out with voltage numbers that make sense, even if you make a mistake on your amps and your ohms. But you do need to double check that and make sure that you put the unit into your table that the table is asking for. All right. Anything else that needs to be clarified? All right. Well, we'll turn off the recording. We'll leave it going for a little while just in case somebody thinks of something. Hopefully these examples are useful. It really is a pretty straightforward lab, but there are a couple things to get hung up on. So it's always good to do that. Oh, and I did not get into the discussion forum. Let me do that. And read what's there. Help and collaboration. Down for a moment. Okay.
I have a question again.
Go ahead.
Number 5, when it's talking about were there any sources of experimental errors in this lab? I mean, when I was looking at every component when we were building it in this simulation, it didn't really specify any type of like the wiring makeup or anything like that. And it says if you had used real components, what sources of experimental errors would you expect to see that were not present in this simulation? Do we just give you like examples, like if there was like human error, or let's say the wiring component maybe like gold versus copper? Is that what you're asking for there?
No, let's talk about that for a little bit, because these are kind of things that you guys might not really know, like if nobody's ever told you, and maybe your textbook wouldn't even address it because this is kind of real world stuff. So normally a copper versus gold or something wouldn't really make that much difference, though it might a little bit. So one of the main assumptions that we always make in circuit labs that is not technically true is that these wires, like everything here, is assumed to have 0 resistance.
Okay.
And technically, actually, there's a little bit of resistance in the battery too, which will mean that there's a voltage drop as the current comes out and stuff. So human error and scientific error are 2 different things. So human error is if you make a mistake and you actually do it wrong. And that doesn't actually ever count when your lab is asking for sources of error. That's not what they're asking for. What they're asking for in the lab is little real world things that, even if a Nobel laureate came into the lab and did this lab, they couldn't get rid of all the scientific error. You could do it properly. You could make no mistakes at all. But things like the resistance of the wires, if you don't add an equation that takes that into account, then you're just not considering it. Now, it's valid to not consider it if the resistance of those wires is tiny compared to the resistance of your resistor. But you always, and the reason why they always ask you about sources of error is because you should always think about that. People who design experiments from scratch and things, they have to decide whether the assumptions they make are valid. And part of that is things like the wires have no resistance. The other thing is your resistor here in the real world, it has a tolerance. So they actually, instead of you can't just go out and buy a resistor for any resistance value under the sun. Normally, and sometimes the resistor tolerance is like as high as like 5, or I think you can even get 10% once. But it might be off by like 5% of the value that it's labeled, just because resistors come out of the factory with a tolerance and they're only labeled at like 5% intervals. Okay. So the resistor will almost always be a tiny bit off what it says it is. The wires will have a little resistance, so that'll throw it off a little bit too. And little things that are kind of borderline human error, like sometimes when you're troubleshooting, your connection might not be good or something, but you also have to consider whether those things affect your results. So a connector would make it hard to do the lab. You would have to troubleshoot and find that. But for the most part, once you did that, it wouldn't affect your results because you fixed the problem. So what they're looking for are any little thing that might affect your results, which would be things like the resistance of the wires and possibly an internal resistance of the battery or something like that.
I see.
And tolerance of the resistors do count, just because that is something that would change your numbers around, and that would account. Basically, if your numbers aren't spot on what they're supposed to be, you have to think about that and decide why not.
Okay.
And it might be little things like that. Any other questions? Okay, yeah, that's a really good one. I know, and it's kind of an ongoing thing. I try to say over and over again that human error and scientific error are two completely different concepts. They don't mean the same thing. And in your lab, they always want you to discuss the scientific error. And the easiest way to identify scientific error are what possible factors are you not taking into account, like resistance of wires. Like we have no equation for that. We could make one, we could put it in, but we're just not doing that.
Thank you for the clarification. That really helps.
Okay, great. All right, sorry, I was still scrolling down over here. Okay, so there's comments in the discussion forum. People are talking about how to actually do it. Yeah, conversion to amps. Yeah, we already talked about that. So if it says little m, big A, then you have to multiply to get, or that's already, yeah, divided by 1,000. So you've got to divide by 1,000 to get the right answer. Okay, it looks to me like most of the questions in the forum have been addressed by the feedback. Someone did ask about max voltage versus DC offset. Did you guys run into that when you did the lab? No, okay, so normally you wouldn't, those are kind of more detailed settings. Normally you would just have a rough, like, what is the value of the battery, and you set the battery value to a certain power. Is that what you guys did when you looked at the lab?
I left it alone.
Yeah, so DC offset is only a thing that exists if you have AC current. And since you guys are using DC in this lab anyway, right? Yeah, I might look at it, but just as a reference to the person, so on the discussion forum, somebody said they have a question about procedure number 5. Do I need to set the max voltage 15 or the DC offset 15 or both? So DC offset shouldn't even exist. Like, it's possible the person made an error in setting it up, because normally you don't have anything called DC offset unless you're using AC. But yeah, you don't mess with that. And it's normally like there's just a flat, like a voltage. Max voltage usually only happens like if you have a limiter or something on it. I will look specifically at the lab to answer that. But it sounds like perhaps that person is in a kind of a weird category in their settings, and you should only have to change basic settings. You shouldn't have to dig into more complex things. All right, so that sounds great for now. Everyone make sure that the questions you asked got written into the chat. I will update the written question in the forum on the forum. So whoever has questions similar to that can check the forum for what we post there. And we will go ahead and tie things up. After this video is processed, I will go ahead and post the link.
Hey, Professor, I got one question before it ends. If I've already submitted it, but just in case there's something that we learned here in this meeting, can I resubmit the assignment?
Yeah, it will. I don't know if it will let you delete your old file. Since it's before the due date, and I haven't looked at them yet, if it will let you delete your old file, just delete the old one and put a new one. If not, it will accept multiple files. So just make a note in the comments section about which one to grade. Yeah, and that kind of goes kind of across the board. You're allowed to change anything up until the actual due date, and no penalties or anything with that. All right. Any other last minute questions or confusion? Okay. Great. Thanks, you guys.